Okay, we are live. Sorry for the delay, guys. There was a little bit of technical issues from our side. We apologize for that. And yes, welcome back for the LLM Bootcamp 0 to Hero in LLMs. Today, we'll be starting with the week 3, module 6, that is pre-trained transformer models, T5 and GPT-3. And we have Mary Aduvunmi, who is a PhD student at UTAS and medical AI coder at Telix Pharma. She'll be explaining how you can get started with T5 models and as well as GPT-3, which are the pre-trained transformer models. So let's get started with the session. So Mary, over to you.
Okay. All right. Hello everyone. Yeah, like Taro said, my name is Mary Adewumi, and I'll be talking about T5 and GPT-3. I know that 1 hour or 45 minutes is not enough for us to delve into this pre-trained project, but I will just try and take my time and explain the details that we need to know about them. Okay, like we all know that we are in the world of generative AI, yeah. So, and that's the hint thing now, is either you're using it for images or you're using it for text, you're using it for audio, video, and all manners of things. So, so I'll be talking about T5 and I'll be talking about GPT-3, like Taron introduced. Okay, so looking at it, what is T5? First, I will take T5. What is T5? It means test to test, transfer, transformer. Test to test, transfer, transformer. It can be used for many other things. It can be used for generative answer, question answering, that GQA, summarization, test summarization. It can be used for all manners of work. So, what are the facts about T5? The model is a type of encoder-decoder architecture which has been pre-trained using a combination of unsupervised and supervised tasks. You saw me stress that word pre-trained. That is, pre-trained means the model, they are ready-made models that you can just use, you can just tap into them and use them. Once whether you're accessing them through API, you're accessing them through web server, you're accessing them through virtual environments and all manners. So they have been pre-trained. So in this pre-training process, each task is performed, is transformed into a test-to-test format. So the T5 model demonstrates effective performance across the range. Yeah, without going to story, I don't want to go. So what we are saying here is that it's been pre-trained. That's just what it's, and it can be used for test transforming. It would convert. It first the way it works. So as time goes on, I will just be explaining the framework, how it works, and everything. Okay, so looking at the variation of T5, we have the T5 small, which has been trained on 60 million parameters. So when you're working with it's showing that when you're working with this model, um, you should have an idea of having large data sets. That's what he's trying to say in essence. Because if you don't have the large data sets, you might have issues with it or something, it might not work perfectly for you. Then T5 base, we have T5 large, we have T5 3B, that has been pre-trained on 3 billion parameters. We have 11 billion, that's T5, 11 billion parameters. On the basis of the original T5 model, Google has released other work, to just battle or to just, push T5. So I would say T5 is old. So I would say T5 is old, yeah. So it said T5 employs scalar relative embeddings, encoder input padding, you know, left to right. I told you it's an encoder decoder, the way it works. Don't worry, as we get there, we'll say. So it's talking about the prompts. So these are the things that the components of T5 prompt templates. We all know about prompt templates. When we are working with chatbot, that writing, when we are saying, oh, ChatGPT, sorry, I'm talking about chatbot, ChatGPT, and you write, oh, can you explain what engineering?
Hello, Mary.
Yeah, yeah,
Are you using any microphone? Because there are
no,
few audience telling that it is echoing.
oh, I'm not using a microphone.
Okay.
Yeah,
So
if
are
it's
there
a,
any two devices?
I've logged out of those devices, so it's only one. Yeah, I've logged
So
out
do
of
we
those devices. Yeah.
We have only one speaker, right? Like only one device. You can only join using one device.
Okay. Yes, I just joined using only one device.
Okay.
So,
Others, can you please confirm whether we are audible or not, or is there any issues?
no. Um. Like. Okay. Is that still issues?
Hi, you can proceed, I guess. One of them said your voice is clear,
Okay.
and there are few more people are telling I do not hear any echo. So you can proceed with it. Sorry in between for the delay. You can continue.
Oh,
Thanks. Thanks, audience.
okay.
Thanks.
All right. So, okay. So, like I was saying, okay. So, talking about it. So, I'm talking about prompts. So, prompts, maybe because I don't know. Yeah. So, talking about prompts are those words, those things that we put, those sentences that we put, like ChatGPT. When you're working with ChatGPT and you put a prompt to write it out, okay, who is this or something, or what is this called or something, or all those things that we put when we're using ChatGPT, those are prompts, prompt templates. So that's what T5 model is all about. The LLM models like GPT, like Bloom. We have a lot of them like that. I intentionally put the GPT, so just to know that they are connected together. Then agents, then memory. So they use the short-term memory and long-term memory. So whenever you're using it, you know that you must have enough memory space, like the RAM. So you get ready to use that. Okay, looking at the framework, it works from down up. Like our data comes from down, self-attention, add and normalize. I told you that for everything it keeps padding. It will pad when it brings in the data. The encoder, when it takes the data, it encode the data, then it takes it to the coder. You could see it feed forward encoder attention. It's using attention transformers. So it adds to it, that is padding it. Maybe padding with zero, try to remove the noise and everything, and add to it and decode it. And that's our soft mass and linear. Those are our metrics for measuring T5. So this is another framework, to make it easier for non-data science survey, just to make it easier to a layman. So President Franklin, born in 1982. So you could see here, he was saying that, oh, D. Roosevelt, he was just talking about the work he's doing. D. Roosevelt was, so you don't know, was born in, so was it D. Roosevelt? That kind of thing. Really couldn't, just talking about what is pre-training, analyzing it and getting the right answer, how it works, pre-training and fine-tuning. Okay, so without further ado, all these are pre-trained models, so we might not go into real detail because 1 hour is not enough to take two models really. So you look at the practice session. So first you install the transformer, then you store the sentence piece. I told you that it works with text into sentences, test sentences. So install the sentence piece. Then you use the T5 tokenizer. I'm just at the end of GPT model, I'm going to use my the GPT miniature model that I did, just to show us how it works. Might not go through because GPU Kuku Collab is always talking about GPU before it tell us that we ran out of our RAM, what's it called again, RAM access again. So you import the touch, so we can just see how this works a bit, yeah. So install the transformer, install the sentence piece, the text generation, yeah. So you can see I got this example from weights and bias, that's WMB. So you could see So it's just going to summarize the text. Once you have, why is it easier? Because it's a pre-trained model. You don't need to write any other model again, because it's been trained on other models. Sorry, on data, on a lot of data. So you might not need to. So you just need to use it. Just import the right requirements. Import the right requirement, maybe requirement test or something. If you have that on their page, and you just use it. So this is going to give us the summarization. You can just go back and we can wait for it to run or something. And this one is just going to give us the German, what's it called, interpretation. Don't know, is it taking time? So you could see here now, the, it's working. It just gave us the loss. I told you that it's working with the loss, right? That to what's it called, to get the measurement accuracy or something, is soft mass loss. So you could see now, so the loss gives us 3.3, which is fairly okay. So you can see the summarization now. Summarize this one. It said the straw hat pirate befriend a pirate hunter and swordsman named Ronald Zorro. So you could see that he was giving, so that means it's not zero shots. It's not zero shots. Zero shots means that we don't have to tell what's it called, the transformer, how we want our model to behave. So we have the few shots, we have the zero shots, I think we have medium or so. So we don't have to tell but if there's the few shots, you put it, okay, this is how I want my transformer to behave. You explain it. But this is just zero shots. We just wanted to see whether it's really working well. I could see that it's brought out the pad that, okay, I've padded this data or these sentences with my own, with my own zero, just to remove the noise and everything. So he said they are joining the journey by, I'm not looking for a perfect example, that's to tell you the truth. I just wanted you guys to have an idea of how it works. Okay, so you look at the language translation. It translates English to German. I love my country. It translated it well, and even it didn't even remember to put the what's it called, to put the full stop, to put the period. So it said each label. I don't know how to pronounce it, so let me do not pronounce it. So you can see that it's worked well, which is a good thing. And he said, oh, the loss item, okay, that's the soft math loss. That okay, this loss. So in case you want to say, okay, how sure it is or something. But this one is for another work. I think it's for dog putting items. I think, yeah, sentence similarity. Sorry. So you could see that it does all manners of things, does sentence similarity. It's telling us that it's showing 4.0, which is a good score, really. So Harrison, but this one is related. Looking at it, Harrison was fighting in the war. Harrison's fighting style is comical, showing the sentence similarity. All these applications, these are things that T5 does. So their pre-trained model makes it easier to use, for us, that especially with the extent or with the large what's it called, computational resources issues that we are having currently. When you're running your model, especially most models now, when you run them, some require GPU access, some require API, but this is handy for us to use, right? So what are the limitations of T5 model? Shorter input sequences, usually fewer than 512. So this is due to, what is this telling us? It's telling us this is due to quadratic computational growth. The input sequences, if they're small, yes, it's using what's it called? Is if you have a large data or something, it's just going to take the sequences that you needed. It's not going to take all. That's the truth. It's just going to take the sequence that I needed using T5. So shorter, so it's might be like this, like definitely is what is affecting this, because it's just going to take the small one and tokenize the small one. It's just going to take 512 tokens. So that is using, so this is due to quadratic computational growth. Computational resources to grow, it's just a repetition, but why is it growing? Because of training time, the training time and memory use. So it has issues with that. Although the training time I would say is okay, but compared to some might say it's not okay, or compared to the latest model that was released after them, the one that Microsoft released and others, they were really faster. So, but I won't say it's a competition. I would say there's computational results, because you could see that it wasn't. If you look at my RAM and disk, it didn't really consume much. Unlike some other models, you see the RAM and disk will already be in red. So that means those ones are no-go area. So, summary of T5 modeling or T5 model training. It uses sentence. It's a sentence piece. It uses text to text, sentence piece, text into 10 sentences. Other parameters, baseline, other factor optimizer. So as long as you put the upper parameters, write the upper parameters, you too can design it or use it. So metrics, lost item, like you've been saying, that's what you use for measuring the accuracy. Data set, yes, the initial data set was used on, that was closer, clean, crud, corpus. That's C4, which contain some dirty languages and some others. It's just a web dump, really. Lessons. So test to test framework make it easy to train a single model on several test problems using the same loss function and decoding technique. So it can work for under, you could see the computational resources, that it wasn't taking too much computational resources once you have a transformer installed. So the architecture too, it says some transform learning has investigated, but found the basic encoder decoder from perform best in the test to test system. This one was developed after so it really works well. The architecture is okay, like the BERT, you have to go through the long, but they already have their own transformer, which makes it easier. So everything but employ twice as many parameters, that is the encoder and the decoder. It first encode before decoding, then after decoding, then it takes it back to encoder. Training to make unsupervised training more efficient, recommend objectives with short target sequences. So whenever you like if you're doing prompt engineering and you see that like this kind of summarization, make it short, as more as possible. Make it short. Make it, you don't need to go into these details, yeah, make it short so that you'll be able to get the right solution, or the right answer, the right fitted answer. So that is all about T5. I'll be expecting your question, and these are the references. I'll be expecting your question in the comment section. Okay, so I'll just move to GPT-3 now. I think I can, right? So okay, so looking at GPT-3, is a generative pre-trained transformer of the third
Hi,
generation.
Mary. Hello.
Yeah.
Okay, so before we move on with GPT-3, we have one question.
Okay.
So, what is the difference between T5 and the vanilla transformer architectures?
Vanilla transform architectures.
It means the basic
Okay,
transformer.
I've seen it. Okay. I really don't know about vanilla transform architecture, but is it developed before T5 or after T5?
It means the basic transformer model. We have the encoder and decoder architecture. So that's
Oh,
the vanilla or basic architecture.
okay, the basic architecture. Okay, T5, the difference between is that T5 is just is a test. It works on tests, right? Talking about because I wanted to know the meaning of the vanilla transform architecture. It works on tests. It doesn't really just work on its own, like compared to other architectures, like maybe the ones that works on images and the rest. But you first encode it, you know. The other transformer, what I noticed about the other transformer is that the other, like GPT or something, they just go straight to the whatever, go straight to the transformer and just do their work. But yeah, you first encode and decode. That's the way the architecture works. You go through the encoder, you go through the decoder before it can work. That is, it has to decode whatever you want to say, remove the noise before it can work. So that's what I can say about, because really I don't really know much about vanilla transform architectures. Yeah.
Yeah, we can proceed
Let's
with
actually
GPT-3.
okay. Okay, so I will just go to GPT-3 now. Okay, so generative pre-trained transformer. That's the full meaning. That is, it means of the third generation. We know that GPT started 2020 officially, yeah, and so it says a neural network learning model trained using internet data to generate any sort of test. It was created by OpenAI. These are just introduction and requires a small amount of tests as input. When it first started, it wasn't a small amount of test, but now, okay, as input, yeah. But
Hello.
when it first started, can you hear
You're
me?
not sharing the screen. We are able
Oh,
to see T5 itself.
oh, sorry about that. So can you see my screen now?
Yeah, now it's visible.
Okay, thank you. So, and it requires a small amount of text as input to generate vast quantities of pertinent. Whenever you're seeing GPT-3, remember our chat GPT because it works on the technology. So, unsophisticated machine generated text. It can be used for chatbots. Sorry for that error. For chatbot generated question answering, summarization, and much more. Okay, so GPT-3 contains more than 175 billion, which was higher than the other. That's T5. Yeah, the parameters you use to train. Before GPT-3, we have Microsoft Turing. Those were the ones developed after T5, which had 10 billion parameters. Was the largest train model then. That was then, but now, we have GPT-3, we have GPT 3.5 Turbo, we have one minus of GPT, we have GPT-4, and I'm sure GPT-5 is the way if it's not here already. So GPT-3 processes incoming tests to execute a variety of tasks involving natural language. It employs both natural language generation and processing to comprehend and generate text in natural human language. So it just what is this saying in essence that it talks about natural human language. Okay, and it has been used to generate significant quantities of articles, poetry, stories, news reports, and dialogue from a small amount of input. Okay, so let me delete this. So, brief history of GPT-3, like it's just there, just story. 2020, OpenAI announced GPT-3, and it was trained, and all these are just the story. So, looking at GPT-3 family, um, yeah, we have the what's it called? We have the GPT-3 small, large. You could see we have 50 plus, 50 plus from GPT-3 family. This one are just telling us how it is, based on their parameters and have others. Okay, now we can see the training parameter by GPT-3 and family. This is just showing the parameters that has been used, to train GPT-3. So we could see how it rose to fame from Hermo in 2018, Bat language, GPT-2, the T5. Now I was talking about T5 was just 11 billion, before Megatron, before T5, then GPT-3. All these ones are just stories. Okay, so looking at the framework. So this is the framework. How does it work? It required and non-required input. That is, you can put jargons. You can put all manners of what it works is it works with our keywords. Keywords. What are the keywords? What are the key parameters that we need, to get our solution or something? So when you send it, when you put your prompt and it said product specific input preprocessing, so it required it pre-process it by filtering it. You can see it filters it, and build GPT-3 prompts. So when you send your own, yeah, it build its own. So, and that's what we call all the GPT-3 prompt optimization, get and filter for prompts from framework. Those are prompt engineering to actually get the right what's it called solution, That's what all GPT-3 make use of prompt. The prompt is very, very important. The prompt aspect is very, very important because that's the basic, that's the baseline for the training. So, sorry, for processing. So process GPT, if fine-tune model, you could see, if fine-tune model, then you release your output and take it. But if it's not, then it takes it to post-processing module and clean it up again. So this is just the framework of GPT-3. What are these applications? Creating promotional content, we know about it, sentence summarization, automated conversational application, debugging, website simulation, sentiment analysis. You can use it to perform all manners of things. They call it, students call them, oh, that's the savior. They don't need to go through Google session. They don't need to go to Google Ask or anything. Now, Google Ask and everything is now becoming a thing of the past. Okay, so for text generation, this transformer is like, so that's, you could see the relationship between GPT-3 and all these transformer models. They are all transformer models. They are all pre-trained, except if you want to build your own model, that's where you start gathering again and build your own transformers. So they are all pre-trained transformer models. So you could see this, yeah, we can just try and run it, just transformer. All this information, if you want more of it, it can be found on Hugging Face. Hugging Face, join Hugging Face, and you see all these models, new model, Eluta, all manners of model, even the Chinese converter, you can see them, this portray model and Hugging Face up. Okay, so you could see, this is just performing all or how it works, text generation and all. But before that, I would like there was this miniature model I built, for colon cancer model. Is a miniature model because I saw them share this tab. So because I saw the need for getting what's it called? Getting um a streamlined information. I just don't want a generic information. I want a streamlined information. So all these Keras NLP, they are all miniature GPT. They're miniature GPT model. So if you want to build model from the scratch, you can start with them. That's the truth. You can start with them. You don't have to go through the what's it called? You don't have to go through others if you don't want to go through them. You don't have to. You don't have to use, although you still need them for tokenizers, especially if you're talking about tokenizers. Okay, so I use this one to build a colon cancer model, a patient-centered model. So you could say, so first I use Keras NLP. It's going to take a long process, but I might not run it. I don't know whether to run it or so. I installed my Keras NLP. I installed Keras upgrade. The data is not held. Oh, did I? Oh, I will have to join the data. So what I did was that I downloaded 10 papers. Let me see whether I can upload my paper, upload them. I downloaded 10 papers. I was actually looking for. Sorry, I'm using another system. Okay, so I wanted a streamlined work, so I downloaded 10. Where are they? Shit. So so you can use any of these. You can use this, whether you want to use whether you want to ensure that, okay, so it's selecting all the tests. So if you want to build a streamlined model, a streamlined GPT miniature model for yourself. So you build it. So I got the test from online. I downloaded it, then clean it up with my regex, clean up with my regex. Then it's talking about Keras NLP, so I installed the Keras NLP. Then the papers, these are the content of the papers. Use 5, it's supposed to be 10, so I'm sure this one is not complete. Sorry, I'm using another system. So I got 10 papers actually and combined them together. When I combined them together, I did request to remove the stopword, the NLTK to remove stopword, and so split the data, don't mind it, this one that is saying 1. So replace the new line. You could see this one is splitting data. So you could see, so I have the 6918 words, test inside the data. So I then replace the data, replace the new, that's the null, replace all the new line with null. This null, so that it can be close together. There won't just be new line as new what's it called, be close together, because it works, with tests. Okay, so you could see my test list. So this is my test list, I selected, tried and removed the first and the second, what's it called, using the selected 1000 to 1005 tests, and so you could see it. So there was no new line there. It has removed it and cleaned it up. So that's the processing stage. So I'm talking about building a miniature model the way they did, following the framework of GPT model. So so filter the test. After filtering, you could see, because if you look at our GPT model, sorry, if you look at share this tab. So if you look at our GPT model, you filter it. I just follow this framework, filter from prompts, so that why we filtering it, so that it has the right keyword. But this one is just prompt. This one is for trained or pre-trained models. So after that, tokenize it. So when I saw the tokenize wasn't working, so I went to go and use the Keras tokenizer, which makes life easier. So there are different transformer models for all this work. You want tokenizer, just go on Hugging Face. There are transformer tokenizer transformers. So just go on Hugging Face and you see a model to use. If you don't have it on Hugging Face, you can go on GitHub, you see a model to use, and just import it. And install the requirement of test. Once you install the requirement the test from the virtual environment, you're good to go. So, and did the test vectorization when I saw that the other one was not working. Then vectorize the data and everything. Hello world, patient centered, because the data can all these models cannot work except they are vectorized. Vectorized means it's converting them into machine acceptable format. 10, how it works. 1011 0 to 9, that's vectorization. So so we look at it. So of course, the good habit is after doing that, what do? You split the data. So I split the data into train, test, and validation data set. And after the whole thing, I started training the model. You see, like train the model with Keras NLP. And it was able to create the model successfully. And so and after it got the random sentence, what's the random sentence. Why was I using this? I was using the sampler, the test sampler, the reduce LR, for the what's it called, parameter tuning, because wanted something that I can see, wanted something that I can see. Sampler is for you to see, is your model really performing? So yes, a deep learning model, but it's going to show whether your model is really performing or is not performing, and after running it, I'm surprised it's not generating it here. I'm surprised. Yeah, I think this should be end of this. So after running it, I got an accuracy, which is a good accuracy of 0.9161. Perplexity is what we use to test GPT model. Perplexity, Roge, and the rest. Those are the metrics compared to T5 that we use soft mass logs. No, we use Perplexity, we use Juroj, I said Juroj, Roj, then value perplexity, yeah, to actually know whether we're on the right track or not. And you're able to create a model. So after creating the model, you could see the truth ultimately. So, and I tested it with my prompt. You could see the prompt response, and I tested with my prompt, said the truth ultimately is really, I use this one is sentence completion. That's okay. The truth ultimately, what's the truth ultimately? Even I intentionally use that word, I intentionally use that prompt because after, although that's not the prompt I later on use, I this one is like what we call outlier. It was totally different from what I was doing, but I actually wanted to see whether it's working or not. So because later on the prompt I was using is that I should explain patient-centered patient-centered care, explain colon cancer in patient center. He got some really well, but he did not get some really well. So what are we saying? Why didn't he get some really well? It was because the data was small. If we are going to train, because those data, this pre-trained model has been trained on massive data sets. They've been trained on millions, billions parameters. So if we are still working with thousands. So that's the what's it called, limitations of, when you want to train the model by yourself. So they said the truth ultimately is really joy in history, this state of light through which, looking at it, it doesn't make sense. I'm sorry to say, it does not make sense, but the parameters. So that's what we are saying in pre-trained model like GPT. So I'm just going to go to this tab again. So what we're saying in essence is that they work very well with enough data. So when you want to start them from scratch, you must have loads of data. You must, if you are not getting to billion, at least get to million, before they can work perfectly. So, and those are the limitations of GPT models. So, and sometimes they give you generalized, generalized, what's it called, information. Sometimes you don't need the generalized one. And another one is that they give without explanation, as in they won't tell you, okay, I got this one because of this, or I got this one because of this. So we are always having issues with that, and that was what I was trying to. I wanted something that can work for my work, and then that can work for me. Because when I saw that, when I went to that and I was asking what's patient-centered colon cancer, it was just giving me general information, which is outdated. I needed more, so I went ahead and built my own GPT miniaturized model that won't take too much of RAM, and that won't take large computational resources. So what are the risks of GPT-3? Plagiarism without references, achieving precision, without references, you are copying because it's been built on massive data sets, right? So you won't be able to differentiate. It's difficult to distinguish between the machine generated and the one written by human. Like that one, if you actually wanted to fine tune it, there is a way to fine tune it. What do I need to do? I add more data. I had more data and try, edit, clean it up and fine tune it. And it will work. It might not work perfectly 100%, but at least it will work a bit, and the accuracy too. So, excuse me, achieving precision. That's why proficiency in mimicking the format of human-generated tests struggles in many applications with empirical accuracy. You could see that model that I showed you was 0.91, but it still wasn't working well. Because why? Because it's overfitting. It's overfitting. So the accuracy, yes, it's accurate. To tell you, yes, it's accurate, but it's mimicking the format of human-generated tests. And the problem is that it might result into plagiarism. That's number one, because it's mimicking the format. It would tell you, oh, and follow the same structure. It's bias. Language models are susceptible to bias, bias in the sense that is what you give, is what you train it on, that's what it will give you. It's not going to bring or think, like human. So those are risk of them, which are being handled by responsible AI and the ethical AI behind all this model. But is a good model. It makes life easy. easy for us. The limitations, yes, like those are risk, and the limitation does not learn continuously. That's tell you the truth. But why doesn't learn it continuously? Because it requires a lot of memory size. It requires a lot of computational size. So you just put a stop to wherever is learning, like it will tell you the number, because the number of tests that you put it determine the what's it called, the length, you know, of his learning. So you have to be conscious of that. Then having a constrained input capacity too. So just like T5 too, but this one is better, approximately 2048 tokens compared to T5 that is 512. Slow time to deduce, absence of applicability, it's just ability to explain and interpret, which was has been sorted out, or is still in the process of getting sorted out, because sometimes when you explain it, like, what kind of explanation? Sometimes it give you some good explanation, but sometimes it give you some explanation that it's not accurate. So summary of GPT model, the corpus. So it works on corpus. So you have to look for how to get data, because it can work well. If you have a lot of data, it can work with zero shot, like give zero shot answers, and the prompt engineering, that's one is very, very important. Prompt engineering is what you give, it gives you back. So the test input, you have to know how to design it very well. And if you're designing from the beginning, you have to take note of when you're designing your prompt engineering, it works with keywords. So you take note of the keywords. And that should be all on GPT-3. Thank you for having me. So I will just await your questions now. Thank you.
Hi, Mary. So there are a few questions. I'll just add them over here.
Okay.
So sorry, Mary. Can you please reiterate your objective? What do you mean by streamlining data?
Okay, streamlining data is to be specific. I did not want the objective of the paper is that I was looking for patient-centered approach, patient-centered care in colon cancer. So, but the patient-centered care entails other form of work, like patient-centered communication, like patient-centered palliative care. Like there's so many other things, so many other specific information. I know that if I don't know about clinical bats and the medical transformer models, but I was just curious, and I just wanted to do something for myself. So, and when I went on ChatGPT, of course I can use ChatGPT for us in academics, so when I went on ChatGPT and it was giving some, I was expecting some things. I was expecting patient-centered care. Sorry, I was expecting patient-centered information. I was expecting post-surgery care. I was expecting palliative care. I was expecting so many other things, but it wasn't giving me. So I was like, okay, I'm an AI programmer. Why can't I just design mine? So that was when I went ahead and do mine. Yeah. So that was streamlining data, specific information.
Okay, so regarding the previous question, right, you were asking what was the vanilla transform architecture. So it was
Yeah.
the basic architecture model that which is nothing but
Attention is all
the
you need.
attention is all you need. And
Thank
there
you.
is a similar doubt, a question. BERT models fine-tuned on various tasks like NER, I guess it's name entity recognition, NSP to perform the task, but how GPT-3 same modules can do many tasks like Q&A, coding, etc., just on the user prompt with respect to even selecting particular models.
Because it's trained on more data than other bats, like bats model. If you see the framework that I showed you, the data GPT was trained on was larger than all that type of model. Billions of data. If you look at the trend, that's why he's able to work more, because these models, they work on the kind of inputs that you give it. like what I indicated or what I showed on my notebook is based on what I give. Is garbage in. I would say, yeah, it's kind of garbage in and garbage in, garbage out. If you don't train it, so those GPT have been trained, they've been collecting the data for a very long time. So, but they're just learning beside GPT. So the parameters, it's going to take the parameters, it's going to take the necessary parameters or hyperparameters it needs, fine tune them, pad them and everything, and makes it, so compared to BERT models and other models, we have GeoBAT, we have all manners of BERT, yeah, I think that was what happened. So the parameters, the number of parameters is higher. That's why it works perfectly.
So regarding the streamline, there was one response as well for that question. Streamline data means we want data in a proper text format to do the pre-processing part efficiently, removing duplicates thing and all. So this was the reply to the question.
No, I was the one that talked about streamlined data. Streamlined data, I wanted something different. I wanted something, yeah, quite okay. Yeah. But I wanted something, what's it called? Just for the work, specific data, just for the work.
Okay, so the next question is, can you please talk through the major steps required to train data with test data and keywords to get the specific output? Thank you.
Okay, like I said, you gathered your data. It depends on the kind of data you want. Mine is textual data. So you gather the data, you clean the data. What do you mean by cleaning it? You can use regals. We have NLTK, that's natural language toolkit. You have regals, regular expression. We have all manners of what's it called for cleaning the data. So cleaning the data means you are removing the stop words, you are removing the what's it called, the quotation mark, the what's it called, the new line, you're removing all those ones. So when you're done with that, then you tokenize the data. You do exploratory data analysis of what you actually wanted, but what you go is tokenizing and vectorization. Why? Because you know that your machine is not going to work or your model is not going to work without what's it called, without vectorizing the data. So you tokenize the data, that is dividing into tokens. You can read more about embedding, word embedding, tokenizing of sentences and all that. And there are transformers too. Like I mentioned the other time, I use Keras transformer. There are transformer that has been designed in that way to tokenize your data, divide it into tokens, and vectorize it. So vectorize, convert into the format that is needed by the system or needed by the model. So when you do that, then you split the data, which is a good what's it called? A good programming habit. You split the data into training, into test, into valid. The train data is the data the model is going to work on, is going to train on to give you so when you train to give you the right model. So sometimes you do the 80 10 10. That's 80% train data, 10 test, then 10 validate. And sometimes you can go through, you can use any other one that you feel you can manipulate. That's a parameter tuning. You can tune the parameter when if you feel that it's not giving you the right answer or giving you the right solution that you actually needed. So when you do that, so you split it. So the test data is actually to test the data, whether it's working very well. Then validate the data. That's the one you use to get your metrics. That's the one you use to get your metrics. So you can, and sometimes you can do test. You can do test and you can do test data. You can do test or validate. It depends on what works for you. And after that, then you can now do the for GPT, you can now do the prompt selection. That's when you use this sentence sampler, to actually say, okay, your sentences, are they working very well? And there are what's it called, codes for that too. And you keep manipulating it. And after then, that's when you now get your results. You do okay, you fit your model, then you get your results. Before you know it, you see the accuracy. Then you check the perplexity. You can check the root score. You can check all manners of that and see whether it's really working well. It's the result, the what's it called? Your output will determine whether your GPT, your model is actually working well or is not working well.
Okay,
Thank you.
so there is one question regarding the hallucination. Is there
Hmm.
any particular component within T5 and GPT-3 that deals with hallucination?
Um, I am not sure of that for the hallucination, but I know that the biobat I've started working on, dealing with some medical issues, because these are issues too that they saw too. They wanted something, they wanted some specific outputs, some specific results, and they were not getting it maybe from the general ChatGPT, right? So as time goes on, I'm sure something will come up with that. I know we've done gene with biobats, we've done gene, we read genes with biobats, and if you can read gene with biobat, that means you can use it to detect diseases, that means you can use it to predict, that means you can use it to get some accurate what's it called, medical information that we need from a patient just with these models.
Uh, I guess that's it with the question. Do we have any other questions until we wind up this? What does barbobet means? Barbet,
Yeah,
sorry.
biobat is BIOBERT. They're just under clinical transformer models. Clinical, the one we use for medical, what's it called, medicine. That's biobat. Yeah, that's biological bats transformers model. Yeah, biobat.
Uh,
Yeah, thank you,
okay.
Satish. Thank you. That's
So, do we have any other questions?
You're welcome, Scotch Raj. You're welcome.
Okay. So yeah, there is one more
Next
update. Since
question.
we didn't add live session on week 2, we will be having attention and as well as transformers implementation live session on 29th. 29th is for module 3 and 30th is for module 4. And the speakers are from PyImage Search. For attention mechanism, we have Ritvik, who is GDE in ML and as well as MLE at PyImage Search. And on 30th, the speaker is Atiraj. Is also the GD in ML and as well as machine learning engineer at PyMed Search. So these are the two sessions which we will have on 29th and 30th. We'll share you the newsletters and as well as the updates on Discord server. So till then, happy learning. Thank you for joining this session. And you can check with the content. We have uploaded all the notebooks which were used in this live session. In the web page LLM Bootcamp. So you will have around two guide articles on how to use transformers and these two notebooks which Mary used in her session. So all the four notebooks are available on Bootcamp slash LLM Bootcamp at AI Planet. So do check it out. And yeah, we'll meet you soon on 29th for attention mechanism. So thank you so much, guys. Thank you again for joining. Yeah, thank you, Mary. Thank you for sharing your expertise and spending your time. So, do you have any other closing thoughts?
Oh yeah, I would just say thank you everyone for having me. Yeah, my work is more majorly medical. I'm a researcher. So yeah, so maybe you want some medical AI work, you can just contact me on LinkedIn. I think there's the notebook has my what's it called details, so you can just contact me on LinkedIn. So I might not be the writing with, but what I do that I use model AI models, for medical AI use cases, especially colon cancer. So yeah, if you are interested in medical AI models and modeling, yeah, you can just look me up on LinkedIn and I me, and I'll be there. So thank you everyone for having me, and thank you, Taron, for the invite. Thank you. Thank you, everyone.
Thank you again. Thank you. We'll see you soon. Thanks.
All right, bye.